Hello, today we're going to talk about how to calculate the pH and pOH of strong acids and bases. So let's review our strong acids and bases really quick. Our strong acids are HCl, HBr, HI, HClO3, HClO4, HNO3, and H2SO4. And our strong bases are lithium hydroxide, sodium hydroxide, potassium hydroxide, rubidium hydroxide, and cesium hydroxide, calcium hydroxide, strontium hydroxide, and barium hydroxide. Okay, so you need to know those because the strong acids and strong bases completely ionize in solution. So that means if you have HCl in solution, it will completely break down into H plus and Cl minus completely. That's useful because whatever your concentration of HCl is, it's equal to the concentration of hydrogen ions. So that can help us really easily find the pH. We can do a similar thing for bases. If I have, say, potassium hydroxide in water splits apart into potassium ions and hydroxide ions. Well, whatever the molarity of my potassium hydroxide is then equal to my hydroxide ion concentration. So I can find the pOH and then the pH from that. Just be careful with some of these that have the 2. So if you have like a calcium hydroxide, splits apart into calcium ions and 2 hydroxides, then you'll do whatever the molarity of this is, you'll have twice as much for the hydroxide ions. So like I said, if you have a strong acid or a strong base, you can just take that strong acid or base. Let's use HBr, and let's say I have a 0.01 molar solution of HBr, and I want to know what the pH value is. Well, so HBr is a strong acid. It completely breaks up into hydrogens and bromines. You could also write it HBr plus water yields hydronium plus bromide. But either of these is fine. So since it completely breaks down, I know I have 0.01 of my HBr, which completely dissociates, so we have 0.01 for the H plus ions. So pH equals negative log of H plus. So pH equals negative log of 0.01, so your pH is 2. And that's how you solve it. You're going to do the same thing for bases, but you'll wind up with the pOH, and you just subtract from 14 to find the pH. Okay, so here's another example. Find the pH of a mixture of 10 milliliters of 0.001 molar solution of potassium hydroxide and 10 milliliters of distilled water. So since we're adding distilled water, that's a dilution. So you can use M1V1 equals M2V2, the dilution equation. My original molarity is 0.001, and I have 10 milliliters of it. What is my new molarity when my new volume is now 20 milliliters? Okay, be careful, that's total volume when you're using the dilution equation. So go ahead and multiply, divide, and you'll get that our new molarity is 0.0005 for the KOH, which is equal to the molarity of the hydroxide ion because KOH is a strong base, it completely ionizes. When I take the negative log of this number, I get that the pOH is equal to 3.301. I should be using proper sig figs here. There's 3, so this should have 2 zeros. So that way I wind up with my pOH. And then for pH, you subtract from 14. And again, when it doesn't specify the temperature, you just assume it's at 25, so we can use that 14. Subtract, pH is 10.699, 3 decimal places, because of those 3 sig figs in our problem. And that's it. It's a basic solution. Okay, so it says, how would you adjust 100 milliliters of a sodium hydroxide solution with a pH of 12 so that it becomes a pH of 11? Okay, so we need it to be less basic Okay, so we need to get it more acidic, but if it's less basic, we need to dilute it. Let's figure out how much we need to dilute it. So, if I have a pH of 12, then I know that my pOH is 2. Okay, proper sig figs. And then if you do 10 to the negative pOH, you'll get that the OH concentration is 0.010. Okay, so that's my hydroxide ion concentration in the original solution. Okay. Now, if I want to get a pH of 11, I know that my pOH needs to be 3. And if I take the 10 to the negative pOH, I'll get that the OH negative concentration is equal to 0.0010. And both of those are molarity. So now that I know my current molarity and my goal molarity, I can use the dilution equation. So I have 100 milliliters of the NaOH to begin with, and its original concentration is 0.01. I'm just abbreviating here for the calculation. I want to know what is the new volume when the concentration needs to be 0.001. And when I solve for V2, I get 1,000 milliliters as my total volume. Remember, that's total. But I already have 100 milliliters. So to actually adjust the pH, I would need to add 900 milliliters of deionized water to that 100 milliliters of sodium hydroxide at a pH of 12. And so that is specifically how you would handle that, how much water you'd measure out and how you would add it together.